Hey, what's up, guys? This is Chung here. So today, number 1,815, maximum number of groups getting fresh donuts. Um, this one is a quite difficult problem. So basically, you're given like a groups of people, right? So and there's a donut shop that bakes donuts in the batches of the batch size, right? And then they have a rule that they must serve all the donuts for a batch before serving any donuts to the next batch, right? So basically, what this one is saying that we have a group of peoples, right, coming into the to the donut store, and in the donut store, the donuts is served as a size of batch, okay? And then when the group visits the shop, all the customers of the group must be served before serving any of the following groups, okay? And then also a group will be happy if they all get fresh donuts, which means that there's no leftover donuts from the previous group. And you can freely rearrange the ordering of the groups and return the maximum possible number of happy groups after rearranging the groups. Right. So for example, we have a batch size of 3, and then we have a 6 group of peoples whose number are 1, 2, 3, 4, 5, 6. And then the happy group, the maximum happy groups we can get is 4. Because first, obviously, with 3 and 6, right, those groups can be served at the beginning because they can be divided by the batch size, right? So then we have 2 happy group already, and then with the third one, with this the remaining one, 2, and 4, 5, right? We can rearrange in a way that 4, 2, 4, and 1, 5, right? Because in this case, let's say if we serve the group 6 first, we serve group 3 second, then this will be 2 happy groups already, right? And then if we rearrange the remaining 4 groups in such a way that let's say we have 4, 2, and 1, 5, right? So we have uh one happy group, second happy group, and then the third one. The third one is also a happy group, right? Because there's no leftover from the previous one, but the but this one is not a happy group because with these 4 people coming in, right? So the previous group number is 2, but our batch size is 3. So which means when the group 4 comes in, right? So there will be one leftover donut from the previous group. That's why this one is a not happy one. And but this one is also this one is a happy one, right? Because 2 plus 4, right? Actually 2 plus 4 equals to 6. So right? Because which means that one donut from previous group and then a new batch size with 3, we can serve exactly 4 people in this one. That's why the next when the next group comes in, there will be no leftover donuts from the previous group. That's why the next one is happy, but obviously the last one is not happy. That's why the total number of the happy group in this example is 4, right? And then another example is like this one, like 4. I think the batch size is it's 9, right? And then the group size is 30, but the groups of people is pretty big. It's 10 to the power of 9, right? So to solve this problem, so when you see like this kind of a pretty small number of the restriction here, so most likely I think this problem will be an NP problem, right? And which means we have to somehow brute force all the possible scenarios with some optimization if needed. Okay. All right. So we have to make a few observations here. I think the first one is that since the group number is pretty big, right? We can simply it's easy to notice that we can always convert this group number into a modular of the batch size, right? Because doesn't really matter how big the group number is. All we care is the remainder after dividing by the batch size. This is kind of obvious, right? That's the first one. And second one, I believe we have already talked about that. Basically, second observation is that if there's any group people that can be divided by the batch size, then we can simply serve those groups at the beginning because we know those will be the happy groups, right? So which in this case is 6 and 3, right? And then the last observation is that after eliminating those groups people that can be divided by the batch size, with the remaining groups of people here, if there are two groups that can if there are two groups that can the total of the group of peoples that can be divided by the batch size, then we want to group those two groups together. For example, this 2 4 and 1 5, right? The sum of those two groups can also be divided by the batch size, which is 3. It's kind of obvious that, like I said, since the total sum is the same, right? The total sum can be divided by the batch size, and then the next group after the bigger group here will definitely be a happy group. So that's going to be the third observation, right? So basically, our logic will be first we convert this group number to the remainder after dividing the batch size, and the second one is that we remove all the groups that can be divided by the batch size. Third one is that we also find how many groups we can find, right? And who's like the sum, right, of the two groups can also be divided by the batch size. And then after these three steps, the remaining stuff, we don't have any other options but to brute force all the possible combinations of that, right? So cool. So I think let's start coding here, and I'll try to explain a little bit more. Okay, so we need the length of the groups, right? So like I said, first we simply convert these groups into a remainder version of that, after dividing by the batch size. So we have a num dual modular of the batch size, right? And then for num in the groups, right? If the num divided by the batch size is not empty, right? Because here, I mean, I also only convert I'm also removing the batch size, the groups that can be divided by the batch size. So that's why at the beginning we already have the answer, right? So at the beginning, the answer will be starting with this one. So basically, this answer at this time will be has already have the groups that can be divided by the batch size. Okay. The batch size, right? So second one is that we need to find the two groups whose sum can be divided by the batch size, right? So to do this, I mean, what we can do here is that we can create like frequency dictionary here. Basically, I'm using a frequency of the counter here, right? And And for basically for each of the group for and this frequency dictionary stores all the count for each of the numbers, right? And then we can just loop through each number in a group, right? For num in groups, right? So we have a so for each of the numbers, we want to find like a matching number of that, right? Which means that the match number in this case will be the batch size uh, subtract number, right? And then I'm going to have like a match equals to 0. So be careful here. Actually, if the match size, let's say, is 6, right? Sorry, if the batch size is 6, and then with number 1, we're trying to find 5, right? And if the number is 2, we're trying to see if there's a 4 exists in this like groups. But the 3 is a like special one because 3 actually is also 3, right? So what I'm saying is that like this. So basically, the match number will be the minimum of the frequency of the number, and then the frequency of the match number, right? Because let's say in this case, right? So if we have 2 ones and 3 fives in this case, so how many groups, how many pairs we can find in this case? We can find at the most 2 because we need to get the minimum amount of 2 counts, right? And then with each of the match here, we have the answer is going to be the match, right? Because we have find those groups with each match, with each pair of groups, we know we can have definitely get one more happy group, basically after this current pair, right? And after that, I'm going to decrease this frequency with the match, right? Frequency of both two numbers, right? So that's going to be the match number divided by the match, right? But like I said, there's a special case here, actually. So when the number and the match number are the same, in this case is 3 here. In that one, we cannot use this minimum because that will double the matched number. Because with 3 and 3, actually, let's say if there are like 7 threes in total, right? So if we do a minimum of those two numbers, so the match will be 7. But it should be, instead of 7, it should be 3, right? Because it's divided by, right? 3 match 3. That's why we have to do a simple check here, right? So if the match number equals to the number, and then the match is what? It's the number divided by 2, right? Else, if they're different, then we can use this like the minimum. Right, so so the reason I loop through from the groups here instead of the frequency itself, it's because the let me think. So actually from the group, inside of the groups here, actually what we can do is we can just do a number from this one, actually from one to batch size, actually, yeah. We can also do this one, right? Because the distinct values in the groups can only be as many as the batch size, right? So as long as we can loop through from the first one to the last one, this one also works, right? So okay, cool. So and and the reason I didn't loop through from frequency because if we do it in Python at least, while you're changing the size of the frequency, the Python will basically throw you an exception. That's why we have to loop through from different data source. Okay, so and after this one, what's left? So what's left in the frequency or any any frequency that still has a count equals to 0, sorry, greater than 0 will be the groups that we didn't find a match, right? So, and those are the groups we need to brute force, right? So then we have a new groups here. So for num and then count in the frequency dot items, and the new groups will be the num times count, right? So that's going to be the total new groups here. All right. Okay, so for this new groups, like I said, to brute force that, we have to use like a DP solution, right? So basically, we try all the possible scenarios. We try at each of the the, the loop here, we try to pick each of the number, and then with each number, we have like so basically the DP, right? So the DP state for this brute force will be two parameters. So the first one, we need to either groups. Actually, we need to remain actually. So, and then we have groups here. So the groups is pretty straightforward, right? Because after picking a group, right? So these groups will be updated. Okay, that's the one. And the second one is the remain. So the reason we need the remain is that we need to know when can we add increase the happy groups, right? So we increase the happy group when this remain is equal to 0. Because after every time we pick a group, this new remain will be updated, and we increase that happy group when this remains 0. That's why we need this two state of this DP function, right? So for the DP, right? So and let's do a DP here. So the first one is the remain, second one is the groups, right? And then I'll just use Python's way of doing the cache here, right? And okay, so assuming we have this DP function here, so in the end, right? So we simply need to return this answer plus, right? Plus a DP of what? At the beginning, the remaining is 0, right? And then the groups gonna be the new groups, right? But in Python, the it cannot hash a list type. That's why we can convert this one to a tuple, right? So that it can be hashed, right? All right, cool. So now let's implement this one. And so the exit condition, if not groups, right? If groups is not empty, we simply return 0, right? Else, we pick each of the DP function here. We try to pick each of the group, and then after that we're gonna have like a new groups, right? So so to do that, I'm going to convert this one to a list here. I think there could be other better ways instead of converting this like tuples from a list to a tuple and from a tuple to a list. I believe we can also use like a bit mask maybe, but 30, I think 30 is yeah, I think we can try also use like a bit mask in this case, but that's just another implementation. But I'll just keep this way here since it's kind of a little bit more straightforward. And so we have answer starting from 0, right? So we try to pick each of the group and range up the length of groups. Okay. And after picking that groups, the new groups will be, so I have a next groups equal to the groups of I, right, plus groups of I plus 1, this one. I know this part is a little bit slow, but I'm just showing you guys the idea here, right? And then we have a new remaining, right? So the remaining will be the what? The remaining plus groups of I, right? And then we do a modular by the batch size, right? And then the answer will be the max. We update the max for each of the groups, and they're gonna be the answer dot. We we increase the groups happy group by 1 when the remain equals to 0, right? And then the remaining will be the DP of the new remain, and then again tuple of the next groups, right? And then lastly, we simply return the answer. So keep in mind that we're checking the remain, not the new remain here, because remain means that we're trying to see with the current groups, because if the remain from the previous group is 0, then it means that we can have like one more happy group starting from the current group. That's why we check this remain instead of the new remain here. Yeah, I think that's pretty much it is, right? And yeah, so let's try to run the code here. Accept it. All right, submit. Cool. So it passed, right? Yeah, I mean that's basically it. This problem, right? I mean it's a pretty difficult one. I I would say that. So first, we have to basically find a few patterns. Like the first one is we find the groups that can be divided by the batch size, and the second one is that we have to find like a a pair, right? That who can form like another groups. Because if you don't do this, if you don't do this one, and you just simply brute force everything after this first step, you will get a TLE, because with this kind of length of groups here, and with the possible state here, it will be too much. But if we can optimize our solutions by removing the matching pairs, right? And then the remaining new groups will be pretty small, which can be brute forced by using this kind of NP DP solution here. Cool. I guess I'll just stop here, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.